Today we're doing lesson 3.9, and your learning goal is to be able to add fractions by finding equivalent fractions. Remember again, what does equivalent mean? What does equivalent mean? Lakshan?
They mean like they have the same value.
Yeah, it means they have the same value or they're equal. Okay, so we're going to find equivalent. We're going to change fractions into equivalent fractions, like different names for the same value, and then that's going to help us add. Have we done this already? But we did this before by using what? Models. And today we're going to do it just using numbers. The day that many of you have been waiting for is here. Now, we've been doing problems where we add fractions. For example, this problem is 1/2 plus 2/3. Can we just right off the bat add these fractions? Can we add these?
No.
Not yet. We need to convert them to have like units because in the first number it's halves and the second unit is thirds, and those are not compatible. But in the past what we've done is we've overlapped them, right, to find what would the like units be? 6. So we use rectangular models to help us find the like units. But today we're not going to be using models. We're going to be using what's called the LCM. Now, what does L stand for? Least. When something's the least, is it very big or is it small?
Small.
So least means the smallest possible. C stands for, everyone?
Common.
So when we have something in common, it means something that we both have that are the same. And what does the M stand for? Multiple. Okay. Now, multiple means when you count by a number. So 2, 4, 6, 8, 10, 12. Those are all multiples of 2. So we're going to be finding the least common multiple to help us find what's called the LCD. Okay? Now we know that L stands for least, C stands for common, and what do you think D might stand for?
Denominator.
Yeah. Now why are we looking for a CD, a common denominator? Why are we using the least common multiple to help us find the LCD, the least common denominator? Why is our goal to get the denominator to be common or the same? Tara?
Because if they're not the same, then you can't really add them
Right.
or subtract them.
Once our denominator is the same, can we add and subtract with no problems?
Yeah.
Yeah, just like we just did in the sprint, right? In our sprint, was the denominator ever uncommon?
No.
It was always common, which makes it really easy to add and subtract fractions. So today we're going to be practicing using the least common multiple as our least common denominator so that we can add and subtract. When you have a problem, here we have 5/9 plus 5/6. We need to look at the denominators that are given to us. What's the first denominator, Drew?
9.
9. And what's our second denominator, Michael? 6. Now remember, we're going to find the LCM to use it as our LCD, right? Okay. So in order to find the least common multiple, we need to list out all the multiples. So what I'm going to do is I'm going to first write my first denominator, which is 9. And some of us can think about this in our head, but for right now, I want us to get in the habit of writing it out. So I'm writing 9 to show that I'm writing a list of the multiples of 9, and that's what the colon, those 2 dots, show. Okay, let's count by 9s. Ready? Go. 9, 18, 27, 36, 45. Should we stop there? Okay, let's stop there. Okay, our next denominator was 6. So let's now write a 6 with a colon to show that now I'm going to list the multiples of 6. Okay, let's count by 6. Ready? Go. 6, 12,
18. 36. 42.
Okay. Let's stop. So in our list, we can see we have some common multiples. We can see that we have 18 that's common. We have 36 that's common. And if we kept going, would we also have 54 that's common?
Yes.
But in this case, we want to use the least common multiple, the smallest one. So which one's the smallest? 18. So ding, 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 18 is our winner. That means that we want to rewrite these fractions. We can say that 5/9, and here is the format for writing it, okay? It's going to be the same as 5 times something over 9 times the same something, which is going to equal something over 18, okay? Now, what do I have to multiply 9 by to get to 18? 9 times what will be 18? Sporty? 2, which means that I have to multiply the numerator, 5, by that same number, which is 2. Do you guys see this middle step right here where I'm writing out this multiplication as a fraction? This is what I am going to be looking for when I see how you converted your equivalent fractions. So if you don't write this down right now, you will not have a good model for what that should look like. So make sure you write this down. Okay, 5 times 2 is 10. So therefore, 5/9 is equivalent to 10/18. Now let's do the same thing with our next fraction. Let's write it down the same way. So we write down our original fraction, 5/6, is going to equal 5 times something over 6 times something to get our equivalent fraction in 18ths. So let's start with what we know. 6 times something is going to equal 18. 6 times what equals 18? 3. So that means I need to also, in the numerator area, do 5 times 3. So 5 times 3 is 15. Therefore, 5/6 is equivalent to 15/18. Now I can rewrite this entire problem as 10/18 plus 15/18, right? Does this new problem, 10/18 plus 5/18, have the same value as 5/9 plus 5/6?
Yes.
How do you know it has the same value? Alina?
Because we converted to the same denominator,
Mm-hmm.
multiply both the numerator and the denominator by the same number.
Yeah, because these fractions over here are equivalent to these fractions, so that this has the same value as this. The only difference is now we've written it using an LCD, the least common denominator. And now we are ready to add. If I have 10/18 and I add 15 more 18ths, how many 18ths do I have? 25/18. Now, is this fraction in simplest form?
No.
No, because the numerator is greater than the denominator, so we call that an improper fraction. What that means is I can separate out 18 of those 18ths. And how many 18ths would I have left? 7/18. So what this equals is 1 7/18.